Recording in progress. This is the second class for calculus in the summer. We learned about limit, okay, calculations, and we learned about this type of limit, okay. We know this equals to 1. Now we are going to work on those questions based on this. I think almost everyone should master this, okay. Let me call a student. Emily. Can you please tell me how do we work on this question? Go ahead, please.
Do I multiply by 2x? So
you want to change the format to be this, right? Because as long as these two things are the same, when x go to 0, you can see this whole thing go to 1, okay? If you keep this guy to be the same on the top, if you want to change the denominator to be 5x, what you want to write down over here?
5
over 2, that's right. Okay. And this 5 cancel, so 2 is here. And now you know this is 1, so the result is
1/2.
5 over 2, correct?
Oh, yeah.
This is 1, this is 5 over 2, okay? You want to always doing this format. If the inside is 5x, you want here to also be 5x so that this term is 1, okay? Thank you. Next one. Lawrence.
Yes.
Let's work on number 2 together.
Okay. This one, I think you can pull out x or 3x on both sides at the bottom.
Sure.
That's what I would do.
Sure, let's go ahead do it. So on the top here, you put sine 3x. And then for the denominator, you take out the 3x.
Yeah.
You're left with x plus
4.
X plus 4, very good.
And
this thing is going to be 1, right?
Right.
Okay. And when x go to 0, 0 plus 4 give you a 4. So the answer is?
1/4.
1/4, very good. Thank you.
Welcome.
Next one. Claire. Let's do number 3 together.
Okay. Do you want to take out like 7x and 5x?
Yeah, we can write this as 2 different fractions, summation. So this is 7x over 5x. And this is sine 4x over 5x, correct? And we can change this 5x to be 4x. And then here we are going to times 4 over 5. Make sense? Now look at here. 4 canceled. So this part is exactly the same as this part. And then x cancel. So this term becomes to 7 over 5. And this term becomes to 4 over 5. That makes sense?
Yeah. So then your total is 11 over 5.
Yes, 7 over 5 plus 4 over 5 go to 11 over 5. Okay? Next one. Is there any volunteer who want to work this question with me together? Any people? No? I'm going to call, okay? Cindy, let's do number 4.
Okay.
What does this mean?
This means approaching 2 from the left.
Very good. Everybody pay attention to here. If I don't write down any number, I'm just writing down x approach to 2, okay? If I write down 2 negative, this means I approach to 2 from the left. If I write down 2 plus, that means I'm going to approach 2 from the right, okay? So here, 2 from the left, that means x is less than 2, okay? This guy implies that x is smaller than 2. So if x is smaller than 2, this guy absolute value should equals to who? Cindy?
It should be 2 minus, wait, hold on.
X. 2 minus x, okay? When we write down x absolute value, this guy equals to x when x is bigger than 0. This guy equals to negative x when x is less than 0, okay? You can put this equal here because x is 0, 0 absolute value is also 0. When you have this guy approach from the left, then this whole package will becomes to negative of x minus 2. So we want to write down here as limit x approach 2 from the left. This is 5x, and then this is 2 minus x. So the sign get flipped and divided by x minus 2. So look at here, Cindy. If this 2 want to be canceled, we left with a negative 1, correct? If we want to cancel these 2 terms, we will have a negative 1 left. Now, how much does this equal?
Negative 10.
Very good, because even though x approach 2 from the left, that still means you want to replace x by 2. So this is 5 times 2 times negative 1, which is negative 10. So the answer is negative 10, okay? But if I change the question here, if I change, say, x approach 2 from the right, then this guy will becomes to x minus 2, okay? X minus 2 and x minus 2 will be canceled. So the answer is 5 times 2, which is 10. Okay, so just by changing a sign from negative to positive, the answer is totally different. But if I change the question again, I don't write down plus here, I don't write down minus here, I just write down x approach to 2. Then the limit at this point does not exist. Because why? Because the limit from the right does not equals to the limit from the left. 10 does not equals to negative 10. So at this point, the limit does not exist, okay? This is a discontinuity. And you might wonder, what will happen for the graph? We definitely can draw a graph. We can see 5x times absolute value ABS x minus 2, and then divided by x minus 2, okay? So the graph looks like this. This is, you see here, on the right, it's from this point. On the left, it's going to this point. This is a jump discontinuity. This is a jump discontinuity. It is also a non-removable discontinuity. Yeah, I want everybody to pay attention to these typical questions. Next one. Aiden,
Okay, so you can factor out a 3 from the denominator.
Aiden, you got two computers connected, right?
Oh, no, I don't think so.
Really? There are two
No, I
Aiden.
think there are 2 Aidens. Yeah, oops. Which one were you calling on?
You.
Oh, okay, cool. Okay, so I think you can factor out 3 from the denominator, and then after that change 1 minus cosine squared x to sine squared x. And then after that, you know, x over sine x is 1. So it's like 5 over 3 sine x, I think.
It's like this, right?
Yeah.
So this is 1. This is 5 over 3. And this is 1
1
over
over
0.
sine.
Oh, so this is dne, okay?
Yeah. Okay.
Thank you. The other Aiden, I think you are not supposed to be in this class. Please log out, okay? Let's see number 6. This is a symbol which you might learn it in the end, at the end of algebra 2, okay? If you haven't learned this before, we can learn this in this class. This is called a floor function, okay? This is called a floor function. And -1, negative, that means you are approaching -1 from the left. You are approaching -1 from the left. So this is, for example, if we want to calculate this value, we can say -1 approach from the left, which is very close to -1, but less than -1. We can choose a point like -1.001. And then 2 minus -1.001 is 2 plus 1.001, which is 3.001. And you choose the floor. Floor means you want to choose an integer number, the greatest integer, which is less than this number. The definition of floor function is the greatest integer less than this guy, okay? This is the definition of a floor of x, okay? And the graph of floor x looks like this. You see, if I try -1 from the right, what will happen? We can give a try. If the question change to limit x go to -1 plus this will becomes to saying, let's do a number, okay? Let's check a number. That means I'm checking 2 minus -1 plus. I can try -0.999. And then this is 2.999. The greatest integer less than this number is 2. You say, why I cannot choose 3? Well, 3 is bigger than this one, okay? You cannot choose 3. You have to choose the number which is less than. and the biggest integer is 2. Okay. So by just changing here from the left, here from the right, the answer will be different. Next one. Olivia. Let's go ahead to number 8. Can you tell me how much is this one? Go ahead.
Um, um,
We can do because when we say here is infinity, here is infinity. The top one will be infinity, the bottom one will also be infinity. We don't know infinity divided by infinity equals how much, but we can do a simple manipulations. Let's give a try by divided by x for both top and also the bottom. 2 over x is this. 5x over x is 5. How much does this guy change, Olivia?
3.
Good. And 4 divided by x, that's this, right?
Yes.
X go to infinity, so this go to 0. This go to 0. So the result equals
Negative 5 over 3.
thank you. That's right. Let's try the other one. Olivia, you can try the same method. Go ahead, tell me how do I do the B part?
Do you divide by x again?
Yes, we do exactly the same thing. We can do exactly the same thing, okay? We do exactly the same thing. The only thing we change here is change it to negative infinity. And you notice that 2 divided by a negative infinity will also be 0. 4 over a negative infinity is also 0. So the answer is the same. And actually, this is a horizontal asymptote, correct? This is those rational graphing, okay? Rational graphing. Remember when we used to draw this rational function by hand? We want to figure out the vertical asymptote and the horizontal asymptote. The next approach to infinity, the y value will be our horizontal asymptote. So horizontal asymptote will equals to this, correct?
Yes.
Okay. And then if we were asked to do the vertical asymptote, we will make the denominator equals 0 and x equals negative 4 over 3. All right?
Okay.
Now, so far, there is just one thing a little bit new. Everything else we already learned last week. This thing we already learned in Algebra 2 and pre-calculus, okay? From this next question, we will learn something new, okay? I want everybody to pay attention because some of those questions is tough, okay? We will work on this question. This is the hardest question for today's class. Let's work on this first. Definition of derivative. So here I need to introduce the definition of derivative. We learned so many different functions, okay? We learned linear function, quadratics, okay? Polynomials, rationals, radicals, okay? Now, given a graph like that, I have 2 points. And if I connect these 2 points, if I use y2 minus y1 divided by x2 minus x1, this is the slope for this line. This is the slope for this line. On a graph, if I can make these 2 points very close, if I can make these points very close, something interesting will happen, okay? If these 2 points becomes to very close, for example, these points move to here. If I connect these 2 points, then this line's slope will be so close to the tangent line slope over here. So as long as these 2 points becomes very close, then the slope here can represent my tangent line over here. That's why this is called instantaneous slope, okay? And actually, the definition of derivative is exactly the instantaneous slope at this point. Because this is calculus class, we have already introduced the concept of limit. So we have no problem to find out the tangent line slope here by making this point so close to here, so that when h, okay, so this point is x, the next point is x plus h. As long as I can make my h approach to 0, then when I connect these 2 points, this 2-point slope can represent the tangent line slope. And this tangent line slope is the derivative. Okay, Newton introduced this symbol. They put a prime over here, and they call this guy as derivative. Okay, derivative. Now, let me show one example. You were given a function like this. This is a function, and you want to calculate the slope at the position when x equals to 1. So we start with this derivative definition. This is the derivative definition. Everybody, you have to know this one without looking at my notes. You have to be able to write down this all by yourself. This is extremely important, okay? Now, fx is this. So fx plus h will equals to, we are going to plug in, okay? Is there any volunteer who want to work on this with me together? No volunteer? I'm going to call student, okay? Angela, look at here. Who is fx plus h if my fx is this?
It's 3x plus h squared minus 7x plus h.
Who is fx?
That's just 3x squared minus 7x.
So I'm going to put a parenthesis, okay? This is the first step. Next, we are going to expand this one. Go ahead, Angela.
It becomes 3 times x squared plus 2hx plus h squared.
If you want to put a parenthesis, you can do it, okay? If you want to do it in one step, this is x squared, this is plus 2hx, this is plus h squared, and then we will do the distribution of 3, okay?
Oh, okay.
Yeah, so how much do I put here?
That's 6hx plus 3h squared.
Okay, that is 6hx plus 3h squared. Next,
minus
Yep.
7x minus 7h
and then,
minus 3x squared plus 7x.
okay. Now we want to do the simplifications. Let's see who can be canceled.
You can cancel 3x squared and negative 3x squared and negative 7x and 7x.
Okay, so we get that guy, and that guy left, right?
Yeah.
And this is the y2 minus y1. This is x2 minus x1. x2 is who? x2 is x plus h. x1 is x. So the denominator is always h, right?
Yeah.
Okay, now let's cancel this h. The 6x and then plus 3h and then minus 7, right?
Mm-hmm.
When h approach to 0, this guy can be gone. This is 6x minus 7, okay? So that means for this function, the derivative is 6x minus 7. If they ask you at point of 1, and you can plug in when x equals to 1, you can see f prime of x equals to 6 times 1 minus 7 equals negative 1. Okay, that's for the question 9, part A. Now let's do the question 9, part B. For the part B, we have to be very careful, okay? Fx is defined as absolute value of x plus 1. For this one, we can draw the absolute value function. X plus 1 absolute value is going to look like this, because when x equals to negative 1, y equals to 0. To the right, this guy equals to x plus 1 when x is bigger than negative 1. So this guy have a positive slope of positive 1. On the left, it is equals to negative of x plus 1. And this is x less than negative 1. So the graph looks like this. Okay, the graph looks like this. But we have to be really careful. Is this function continuous? Aiden, can you tell me that is this function continuous?
Yeah, I think so.
Okay, because when you approach this from negative 1 from the left, this guy approach to 0, right?
Right.
When you approach this function from the right, this guy limits also go to 0, yes?
Yeah.
Okay, next. The limits from the left equals the limits from the right equals to a certain number. So the definition say limits fx exist at x equals to negative 1 and equals to 0. Next, let's calculate the function value itself at negative 1. F negative 1, function itself at negative 1. Negative 1 plus 1 equals to 0. This equals 0. So f of negative 1 equals to the limit when x approach to negative 1. The conclusion is fx is continuous at x equals to negative 1. Okay, so whenever you will ask to define a function as continuous, you have to show 3 steps. You can't believe when we learned calculus, we are going to do something like we are doing for ELA. We have to write down paragraph 1, you have to show the limits from the left, the limits from the right, both exist. Paragraph 2, limits from the left equals to limits from the right. Okay, so that the limits at this point exist. Number 3, you have to check the function value at this point. And this function value at this point equals to the limits when x approach to -1. Then you can conclude that this guy is continuous. Only if your function is continuous, then you can be derivable. But it doesn't mean that as long as you are continuous, you will be able to be derivable. It sounds very confused, but this question will explain. This function is continuous. So you say, teacher, this looks so complicated. I just care, how do I prove a function is continuous? Here is a simple way, okay? I'm using my Apple Pencil 2nd generation. As long as I can draw the graph without lifting my pen, then this is continuous. If I have a graph like that, and then I have the graphs go that, I'm not able to draw this one without lifting my pen. So that becomes to discontinuous. But this guy is continuous, okay? But if I on purpose make this guy to be a hole, then this guy becomes to discontinuous, because when I draw here, there is a hole. So I have to lift up my pen and then redraw, okay? For this question here is continuous, but the question is asking you, what's the derivable at this point? Look at this. The derivable from the left, which is your slope, equals to -1. Your derivable from the right equals to +1. This 2 does not equal. So the point here is not derivable. The point here is not derivable. Okay? So far, is there any questions? Any question are welcome, because the next one will be really complicated. Let me teach this in another way, okay? There are 2 different formats for the definition of derivative. First, you are using this one. This is called the original definition of derivative. And the second way for the derivable is using this guy. You see, they are the same. They look the same, but a little bit different. This guy, you want to make the x change to be close to 0. The other one, you just get 2 points. One is called x, one is called c, okay? And you used to say they're increasing, go to 0. Now you see this point approach to the other point. So if we want to use the alternate form of derivable, we use this guy, we redo this question. They ask you, does the derivable exist at this point when c equals to -1? So based on this format, the derivable here equals to this. Fx is defined by x plus 1 absolute value. At Fc, this is f of -1 because x approach to -1, okay? Now, you have x plus 1 absolute value. And you know that f -1, and you know f -1 equals to 0. So this guy is 0. And then the denominator is x minus c. c is -1, which is x minus -1, which is x plus 1. So you got here. Okay? And we already did this question at the beginning of the class. This guy, when x approach -1 from the left, this equals to -1. When x approach -1 from the right, this equals to +1. This 2 does not equal. So if this 2 does not equal, okay, this 2 does not equal, then this guy does not exist. This limit does not exist because the limits from the left does not equals the limits from the right. So the limit at this point does not exist. That's why the derivable does not exist, okay? You want to write down these notes, including every single step that I have here, because for all your high school, when you are going to do those similar questions, your teacher will give you the grade according to if you have this, if you have this, if you have this, if you have that. Did you write down all those things? Okay. This is looks like small essays for calculus. That's part B. Now part C. Part C is a really complicated question. I will hold C, okay? Let me hold C. We will come back to C. This is for those students, for those AMIs, okay? AMC 12 and AMIs. This question is beyond most students' current foundations. Let's see the number 10. I will, hold on. Go ahead. Based on the definition, I want everybody, go ahead, do your work. I leave my apples here. This is my apple. I want everybody to go ahead and do this using these formulas and apply to number 10 and find the f prime of x. If you finish this, go ahead and text me your answers. Let's see who can get this correct. You can go ahead now. If you have trouble to write down this formula, here is my hint. Okay, we reviewed the Pascal triangle and binomial formula last week. I suppose everybody should master this already. Has anybody finished this question? No? Nobody finished? Okay. Now let's do this, okay? Let's try this way, okay? We use this definition. This is the definition of the derivable, okay? Derivative. So we want to start from this definition. Fx plus h is x plus h cubed minus 2 times x plus h plus 1. Olivia, you got it. Very good. Thank you. Smart girl. Let's do this together, Olivia. Since you already finished, go ahead, just read me your answers. Let's work on this. Go ahead.
Okay, so x plus h cubed minus 2 times x plus h plus 1 minus, and then in parentheses, x cubed minus 2x plus 1.
Very good.
And then I just distributed all.
Sure. Let's go ahead, do it.
Okay, so x cubed plus 3x squared h plus 3xh squared plus h cubed minus 2x minus 2h plus 1 minus x cubed plus 2x minus 1.
Very good. Now let's go ahead, do the cancellations.
Okay, so you can cancel x cubed and negative x cubed, and also negative 2x and 2x, and 1 and negative 1.
Okay. So we
and then-
get, that's
So-
what we have left. Yes.
Yeah.
And then what do we have?
And then you cancel out the h from,
Yes,
so
that h can be gone. Yes.
yes, so I got 3x squared plus 3xh plus h squared minus 2.
Okay. And then h go to 0. This is gone. Okay. That's the
Yeah.
answer. Very good. Thank you. Very nice. Next, we are working on the hard question. Okay. And let's look at this. The question is asking you, using the definition of derivative to find out this guy's derivative. Okay. Before I show my answer, you can give a try. Maybe we have some really smart kid in this class who can find out this using the definition of derivable. Okay. Let's use the definition of this to find out the derivative at here. You can give a try. So basically it's this. And we want to calculate this guy's limit. How do we calculate the limits for this guy? This looks very ugly, right? I show some hint here. You can use something called U substitution, okay? You can use U to represent this. You can use V to represent this. If U is x plus h plus 2 square, and V is x plus 2 square, then this guy is U to the power of 1/3. This part will be V to the power of 1/3. Aiden, let's try this together, okay? Aiden,
Yeah, okay.
let's try this one together. So this is using the definition, right? We have
Right.
this step is not hard. But looking at this, previously we can use those square formula or cube formula or even to the power of 5 to the power of 6, no problem for us. But we
Yeah.
never ever learned about that. We don't have formula for that, right?
Right.
We don't have formula for that. But here is a trick. If we use that guy called U, and we use this guy called V, then this becomes to U to the power 1/3. This becomes to the power V to the power 1/3, correct?
Correct.
So this becomes to this. No problem, right?
Yeah.
Okay. Now this becomes way more simple than the other. How do we change this? Did we learn something called a cube minus b cube equals
Yeah.
to a minus b times a squared plus ab plus b squared? Do we have this formula?
Yes.
Okay. So when I see here, I feel like as long as I can have u to the power of that guy square plus this two guy product plus that guy square, I can times this on the top and I can times the same thing on the bottom. That makes sense?
Yeah, that makes sense.
Okay. I will go a little bit slow because this is a hard question. So everybody, please go ahead and write down this. Make sure you truly understand this step, okay? If there is any question, please ask me. I want everybody to be able to understand this question. This guy is u to the power of 1/3. This guy is v to the power of 1/3. So my original one equals to this. This guy are same as this guy. And I noticed that if I can match by times the same thing for the top and the bottom, this one is equivalent to the previous one, correct, Aiden?
Yeah.
Okay, now I feel happy because look at this. How much is this? This guy times this guy equals to?
It's just u minus v, right?
Yes, because this is a minus b, this is a squared, ab, b squared. So this is a cube minus b cube. A is this, b is this, so this is u, this is v, correct?
Correct.
Oh, up to here. Can everybody give a try? Can everybody give a try from here? Go ahead, try yourself. If you finish the question, you can text me your answer. You can move forward from here. Now, this is a math competition level question, okay? Anybody get the answer? Don't feel scared just because this question looks ugly, okay? You want to challenge yourself, say, I can do it. All right, then let's continue. This is U, this is V, and the denominator just copy down, right?
Yeah.
Okay. Now, watch out here. U minus V. So we have to bring this guy back. And then bring this guy back, right? U is
Right.
this guy square. V is this guy square. Well, you can expand this one, and we shouldn't have trouble to expand. This is easy. This is x squared plus h squared plus 2 squared plus 2xh plus 2 times x times 2, which is 4x, and then plus 2 times 2 times h, which is 4h, and then minus this, okay? Or we notice that u minus v is somebody square minus somebody square. We know the square difference formula. This minus this equals to x plus h plus 2 plus x plus 2 times x plus h plus 2 minus x minus 2, correct?
Yeah, correct.
This guy difference come to here. X plus h plus 2 plus x plus 2 times parentheses x plus h plus 2 minus x minus 2. Okay. When you see here, when you see this, you start to feel scared, but you can manipulate the formulas we learned before. Well, this canceled, that canceled. X plus h plus 2 plus x plus 2 was left. This is h, this is h. H and h can be gone. Now, u and v, we want to replace back by x and h. So u to the power of 2 over 3. U to the power of 2 over 3. U to the power of 2 over 3 equals to that guy. Square times 2 over 3, which is 4 over 3. Okay. And then plus that guy. which is that guy to the power 1/3. And then times that guy to the power 1/3. Go to here. And then plus v to the power of 2/3. V to the power of 2/3, which is that guy to the power of 4/3. Okay. This canceled. We have this guy and this guy. And you said, teacher, this looks so ugly, okay? Don't worry, because h will go to 0. All those guys will be gone. The top one is x plus h plus 2 plus x plus 2. When h go to 0, that guy is gone. So 2x plus 4. And then the denominator is very interesting because look at this. H is gone. So this is x plus 2 to the power of 4/3. H is gone. So this is x plus 2 to the power 2/3. X plus 2 to the power 2/3 times this guy again itself. Exponential property. You plus them together. That equals to x plus 2 to the power of 4/3. This is same as this one. Believe or not, that guy are exactly the same guy, even though they look so different, okay? You need to wash out their makeups to see their real thing, okay? So this is x plus 2 to the power 4/3. This is another one. This is another one. You have how many? You have 3. 3 times x plus 2 to the power of 4/3 on here. This is 2x plus 4. You can definitely take out 2/3. And this is x plus 2. This is x plus 2 to the power 4/3. So this is 2/3. Here is 1. Divided by this, you do 1 minus 4/3. You copy down here. This is x plus 2 to the power of -1/3. That's the answer. So far, any question? I have the recording, so if you think I teach too fast, you can look at the videos after the class. If you think I teach too slow, text me a message, okay? Yeah, please give me comments. If you think the thing I teach you is too fast, you can check the videos after class, or you can ask me to pause a little bit during the class. If you think the thing I teach is too easy, also let me know, okay? All right, we have this answer. Students, don't feel frustrated if you are not able to solve this question by yourself, okay? As long as you can figure out this question and this question by yourself, you are already good enough. For this one, because you never used this format before, so you can practice this by yourself with my notes, then you master this. If you have trouble to do those manipulations to get the answer for this one, don't feel frustrated. This is for students who do the math competitions like AMC 12 and AMIS, okay? But I still like you to know a little bit about this. What will happen if your school give you a challenge question like this? You can give a try, okay? And then you can show off everyone, see, wow, I can do this. This is really high level, okay? All right, now we are going to do some magic, okay? Yeah, because the question here looks complicated. Let's do some magic. Let's have a magic show, okay? Are you ready? We are going to do this. I'm going to show those derivable in 1 second, okay? Look, everybody pay attention. Let's watch out here. We want to get the derivative. Now I'm going to show you how do we get it quickly. Question A, look at here. This is 3, x to the power 2. Put 2 here. And then x to the power 2 minus 1. Minus 7. X, this is 1. 1 minus 1 is 0. X to the power 0 is 1. So here is 7. So the answer is 6x minus 7. You see, really? Is this true? 6x minus 7. Yes, they match. Now, this one, the derivative doesn't exist, okay? So we don't have any formula for this one. This one, watch out. Even though this guy looks so complicated, we still can get the derivative in 1 second. Look, 2 over 3, copy down, put in front, x plus 2 to the power of 2 over 3 minus 1. This is 2 over 3. This is 2 over 3 minus 1 is negative 1 over 3. That's it. You see, really? Is this really true? Look. Are they the same? Are they the same? Yes, they are the same. Now let's see here. This guy, derivative, this guy equals 3, put in front, x to the power of 3 minus 1, which is 2, and then minus 2. Okay, x to the power 1 minus 1, that's 0. So 2x derivative is 2. Constant value derivative is 0. That's it. You can confirm. 3x squared minus 2. 3x squared minus 2. That's it. Okay. Feel happy now? And we can do it very fast. So this is the famous power rule. Okay. Let's do this. Let's call this power rule. And you want to see power rule is really powerful. You have x to the power n. If you want to get the derivative, that equals to n times x to the power n minus 1. You say, teacher, does this apply for any number? Yes. When n is integer, this is definitely true. If n is a fraction like that, it is also true, okay? It applies for any real numbers of n. Okay. So far, any questions? Yeah, if this question I teach too fast, you can check the videos to understand every single steps. Now, we will come to the next topic, okay? Using the definition of derivative is a critically important thing. Let's see the next question. Our next question is very easy. They ask you find the average and instantaneous rate of change. Average rate, look at this. They ask you average rate between 2 and 8. Go ahead, everybody. This is your x1, x2. This is your y1, this is your y2. This is algebra 1, okay? Go ahead and do this. Text me your answer. This is super easy. Everybody should give me correct answer. Go ahead, text me your answer. Average rate over 2 to 8. Very good, Olivia. Olivia, you already get this one. Can you please go ahead to here? Let's find out the instantaneous. And you say, no, I don't have the function. I'm not able to use the power rule. I cannot do the instantaneous. Look, if 2 points are very close, you can use the 2 neighbor points to represent their midpoint instantaneous rate. Okay, so you can do this guy over this guy to find out. Okay, we got Olivia, Aiden, correct answer. Other people, text me your answer. I need to see your answer. Please text me to the one which I send out the messages. Okay, I have 2 computer login at the same time. Send to my account which I send out to you the message. Yeah, we have Olivia, Aiden, Angela. Who else? Did you send me to the other one? Oh, I received some message over here. Okay. The average rate is just by doing this. You use this minus this over this minus this. That's it. Okay. And the instantaneous one, you use y2 minus y1 over x2 minus x1. This is algebra 1. Okay. The question here is only ask you for algebra 1 questions. This is algebra 1. Next. Question 12. Well, I suppose everybody in this class already learned algebra 2 and the pre-calc pre-AP, okay? And you should be able to find the factors and rewrite this one. When x does not equals to 3, this can be canceled for the factor of x minus 3. So this is x plus 3. When x equals 3, this is undefined. So the graph looks like this. For that point, you have a hole there. This hole is called a removable discontinuity. When you draw here, on here you have to jump and then you can continue draw. Okay? For this graph, we can easily factor out this guy by x minus 2 times x plus 1. And this is 2 vertical asymptote. X equals -1, x equals to 2. Okay? And then the horizontal asymptote is this. And I believe everybody can draw the graph here. Yes. These are all non-removable discontinuity because you see here, when I draw this part, I have to lift up my pen to draw this part. And then I have to lift up my pen to draw this piece. Okay. So this is called jump discontinuity. This is also belong to non-removable discontinuity. Those questions we already learned in pre-calc and algebra 2. Next question. I want to challenge everyone. Go ahead, find the k value so that f will be continuous at x equals to 3. Now give a try. For what k value can make this guy continuous? Okay. For what k value will make this guy be continuous? And you might say, what do you mean? I don't quite understand this question. So, wow, Olivia, you're so good. So let's, for example, if k is 2, so 2x squared on the left, x is less than 2. Yeah, we already get 2 smart kids get the correct answer, okay? And the other piece is 2x, if I suppose k equals to 2. And then this is a piecewise function. Okay. Yeah, this is obviously showing that this function is not continuous. Okay, it has a jump discontinuity or non-removable discontinuity over there. But if we change the k, I already have, let's see, I have Olivia, Cindy, Angela, give me the correct answer. Okay, 3 students got the correct answer. So we are going to put k as 4/3. Okay, and the other guy, I'm going to make this guy as 4/3. So this is beautiful. This is really continuous. Okay, this is really continuous. But listen, that point there, this point there is called a cusp. This is called a cusp point. Even though it is continuous, but you look at this, this is not smooth, okay? That point is not smooth. The slope from the left does not equals to the slope from the right. If the slope does not equal from both sides, on this cusp, CUSP, on this CUSP cusp point, this function is not derivable. This function is not derivable. Yes, it is continuous, but it is not derivable. And the question is not asking you derivable or not, it just asks you continuous. So what you do? When x go to 2, limits from the left go to a full k. When x go to 2 from the right, that is 4 plus k. You make this equal, k equals to 4/3. Don't underestimate this question. Every year for the AP Calculus test, College Board test, doesn't matter it is A, B, or BC. I guarantee you they have this question for sure, but way more harder than this one, okay? This is the easiest example. Well, the last topic we learned today is called IVT, okay? In calculus, there were hundreds of theorems we need to learn. One of them is called intermediate value theorem, okay? We call it IVT. Let's see examples. They ask you, they give you this function and they give you a domain, which is from 1 to 4. And they ask you, does IVT holds here, okay? And they ask you to say, the question basically is asking you this. You have a graph called x minus 3 squared plus 2. So the vertex is at 3, 2. And you have 2 points. One is at 1, one is at x equals to 4. And they ask you to say, can you guarantee that from here to here, you have at least 1 point which make your FC equals to 5, okay? Without graphing, can you guarantee that you have at least 1 point of C which make your FC equals to 5? So the power tool we are going to use here is called IVT. As long as you can prove that your K value here, as long as this guy is between of F1 and F4, or you do this, as long as you have this value between of F of this one and F of this one. That's number one. Number two, you have to make sure the function is continuous on this domain. If you can make sure these two things correct, then your IVT will apply, which means you will have at least one number which will make your f of c equals to 5. Okay. So this sounds very complicated, but the question itself is easy. You just follow my format. What we need to follow is, you say number one, that function, you know this function is continuous, right? And this is the easy quadratic. For sure, it is continuous. It is continuous negative infinity to positive infinity. So it is also continuous on 1 and 4. Step 1. Step 2. F of 1 equals to how much? Well, you can plug in. F1 equals to 6. F4. F4 equals to 3. How about this guy? Well, 5 is between 3 and 6. Okay, you want to write down like that. After you finish these two steps, you say, number 3, based on IVT, there must be at least one number of C, which you satisfy this, and FC equals to 5. So you have to show the work. Remember, you have to know this. If you don't write down the keywords is, the teacher are looking for this. The teacher are looking for this pattern. The teacher are looking for this, and also the conclusion. If you didn't write down this, wrong. If you don't have this pattern, wrong. Okay, you have to show this. And in AP test, they have a free response question. They might ask you this kind of questions. The question here is simple, but in the AP free response question, and sometimes it becomes complicated, but the key words is, do you have this? Do you have this? And this, okay? If you don't mention here and here and here, and you just say that, you just get 1 point out of 10. So this is for the IVT, okay? I'll give you a few minutes. You want to write down the notes. Any questions so far? For everything I have teach today, please ask me any question, okay? Any question? No question. All right. Let's play some games about always, never, sometimes, okay? Yeah, let's do here. See. If the function is non-differentiable at x equals to c, then the function has a vertical tangent at x equals to c. Look at this. What does this mean? So look at this. This is those absolute function. We already know that because even though this is continuous, but the derivable here does not exist because the slope from the left does not equals to the slope from the right. So that point is called non-differentiable. Non-differentiable is the same as non-derivable, okay? Which is the same as the derivative on this point does not exist. They are the same words. Differentiable, derivable are the same, okay? Non-differentiable. So this point is non-differentiable. And then they say the function has a vertical tangent. That's for this scenario. If you have a vertical asymptote on that point, yes, you have vertical tangent here. But here, this guy does not have vertical tangent, okay? So the answer for this one is sometimes. Not always, not never, but sometimes. Because you can find those counter examples and you can find the true examples, okay? So this is called sometimes. Look at 15. If the limit exists at x equals c, then the value of the function exists. This is no, because you can draw this kind of graph and you can on purpose make a hole over here and you can put another value here. Look, this value there, that's the limit. This point is the function value. This is the function value. Does this guy limit exist? Yes, because the limits from the left equals to the limits on the right. So the limit exists. But their function value is not equals to the limits here. So this is a removable discontinuity. It is not continuous. This guy exists. It doesn't guarantee you have a value here. This is called sometimes. You can have graph like that. You see, the limits and the function value are the same. Okay, so we have many examples. Any kind of continuous function can support. Any kind of continuous function can support this one, but this one is a counterexample. So this is called sometimes. Okay. 15. If the limit does not exist at x go to c, then the function is differentiable at x equals c. So what does this mean? This means the limits does not exist. So that means you have to, when you draw your graph, you have to lift up your pen. Okay, so you have something like that. The limits here does not exist. You from your left, you from your right are not the same value. And they say is differentiable. Oh, come on. To be differentiable, you have to be continuous first. You are even not continuous. How can you be differentiable? So this is never. This thing will never ever happen. This is never. Next one. If the limits exist at x equals to c, then the function is continuous at x equals c. Oh, we already explained this question. This one is same as that one. The limits exist. Doesn't say your function here equals to the limit. So this is sometimes, and you cannot say this is always true. Okay, this is sometimes. Next one. If the function is continuous, then the function, well, no, not at all. You have those absolute value, or you have a necklace like that. Any of those cusp, let me write down this. This is called a cusp, C-U-S-P. All those kind of sharp turns, those cusp shows that this is wrong. Continuous does not guarantee you to be differentiable, okay? But the differentiable guarantee you to be continuous. Continuous does not guarantee you to be differentiable. Next one is easy. If the function is continuous, then the value of the function exists. That's right. If the function is continuous, then the function at x equals c exists. This is always true. Okay, I have those recordings. If you think I do too fast, you can check it after the class. Fx has an absolute value minimum at x equals c. Then the function has a corner point at x equals c. Look. If I draw my graph like that, okay? If I draw my graph like that, this is a decreasing, okay? This is a mono decreasing function. And it has the absolute minimum at x equals c. Yes, for this one, this guy is a corner point, which means it is one edge. It's at one edge. So this is the one correct answer, which is supporting this one. Does this make this always true? You have to check. If you draw a parabola like that, this function, that point is the minimum, not only the relative minimum, but also the absolute minimum, because this guy is the lowest point among all this graph. But this guy is not on the corner. This guy is not on the edge. So this one is the counterexample. That's why you choose S. That's why you cannot choose always, okay? Same one for here. If fx has a local maximum, if fx has a local maximum at x equals c, then the derivative equals 0 at x equals c. So you have a graph like that. They have a local maximum, okay? For this one, yes. When you have this guy here, derivative equals 0. This go to minimum, this go to maximum. The derivative here is 0, here 0. But you forget about those scenario with cusp. This guy, it has a maximum here, but the derivative does not exist at the cusp point. So to do those sometimes never always question, you always want to use those cusp to help you get the correct conclusion, okay? Now, same thing for here, okay? Other question I don't think is difficult. I have all my explanations over there. You can check my answer. Here is my, let me upload, okay? I give you the blank version and the one with my notes. I will also upload the videos. You can check out the videos when after I've sent you the link, okay? Make sure you finish the homework, okay? That's for today's class. I'll see you next week. Thank you.